Alright, in previous section we talked about how to find the inverse of a function, and if we had y is equal to 2 to the x, we now know that the inverse of this function is log with a base 2 of x, and I should say write y, and this is really kind of y raised to the y. This is the inverse of y. And remember how we were able to tell if two functions were inverses each other by doing the composition of a function, taking this guy and plugging it in for x here and so forth, and taking this one, plugging it in for x, and we should both equal x. That was something that we talked about in a couple sections ago. But now basically what I want to do here is just graph these guys out and take a look at their graphs. So let's do that. Alright, this blue line right here is the graph of 2 raised to the x, okay, the exponential function, and then this graph here is the graph of log with a base 2 raised to the x. Now in most graphing utilities you can't just graph log with a base 2 of x. Alright, you've got to do something special to it, and we'll talk about that in the log properties. You'll have to rewrite that and to be able to actually graph it. But it's no big deal. And that also goes for plotting points, if we were to sketch this out by hand. But we can take a look at this because these are both inverse of each other, alright, and inverse functions of each other. And of course this is y is equal to x, and as you can see here they're a mirror image of each other. I'm going to, let's see, can we move the graph? Yeah, we can move it. As you can see here, as x gets closer and closer to 0, as you can see my y value decreases, right, is really decreasing here. Just kind of throw that in at you. Let's take a look at some others. Alright, this blue graph right here, this is a half raised to the x power, and then this graph here, you can see this has a base of a half, log base of a half of x, as you can see, decreasing. So let me actually write that out so you can see that. We have y is equal to a half raised to the x. Now that was the this part of the graph coming down and decreasing like this, and then so its inverse was going to be y is equal to log base is a half here of x. Alright, and remember that that's going to be a mirror image of this, and this actually, let's use a different color, it's green, we'll use green. And so this one's coming down like this, it's going to cross, it's going to be the intersection point right here, and then it's going to come down and do something like that. Alright, so remember both these graphs are a mirror image about the y is equal to x right here, as you can see. Okay, so this is just a little summary here on how to graph logarithmic functions and exponential functions, and noting that these are inverses of each other. And of course we talked about how to go from exponential form to logarithmic form. So this should give you at least a basic understanding of the log function, and I did talk about the natural log, and that's if the base here was e. Right, the base is e. In the next section we're going to be getting into the properties of logarithms, and then I think we're going to have some logarithmic equations where we're going to actually solve for x, because we're going to have things like, for example, with this exponential equation here, where we're going to solve for x, and we're going to do that using the log function, or we could use the natural log function. It doesn't matter, you'll find out. But this is going to get down to being able to solve exponential equations where we weren't able to do this previously, especially something like this here. Alright.